Hey people, it's Niles talking. This is from the mail. Artificial photosynthesis device makes clean fuel by mimicking the ability of plants to convert sunlight, carbon dioxide, and water into energy or electricity. A new device is able to take in sunlight, carbon dioxide, and water to create a new carbon-neutral fuel without any outside source of electricity, its developers claim. University of Cambridge experts behind the device says its use as a form of artificial photosynthesis, the process used by plants to convert sunlight into energy. The device is based on an advanced photosheet technology and converts sunlight, carbon dioxide, and water into oxygen and formic acid, a storable fuel. The type of fuel can either be used directly in a specially developed generators or by converting into hydrogen, according to the Cambridge team. The wireless device could be scaled up and used on energy farms similar to solar farms producing clean fuel using nothing but sunlight and water as its input. Harvesting solar energy to convert carbon dioxide into fuel is a promising way to reduce carbon emissions and transition away from fossil fuel, experts claim. However, it's challenging to produce these clean fuels without unwanted byproducts that are costly and complicated to remove. It's been difficult to achieve artificial photosynthesis with a high degree of selectivity, so you're converting as much of the sunlight as possible into the fuel you want rather than be left with a lot of waste, said first author Dr. Qian Wang. Senior author Professor Erwin Reisner said storage of gaseous fuel and the separation of byproducts can be a complicated process. We want to get to the point where we can cleanly produce a liquid fuel that can also be easily stored and transported. In 2019, researchers from Reisner's group developed a solar factor based on an artificial leaf design, which also uses sunlight, carbon dioxide, and water to produce a fuel known as syngas. The new technology looks and behaves quite similarly to the artificial leaf, but works in a different way and produces formic acid. While the artificial leaf used components from solar cells, the new device doesn't require these components and relies solely on photocatalysts embedded on a sheet to produce a so-called photocatalyst sheet. The sheets are made up of semiconductor powders which can be prepared in large quantities easily and cost-effectively. In addition, this new technology is more robust and produces clean fuel that is easy to store and shows potential for producing clean fuel products at scale. The test unit is about 3 square inches in size, but the researchers say it should be relatively straightforward to scale it up to several square feet. In addition, the formic acid can accumulate in solution and be chemically converted into different types of fuel. We were surprised how well it worked in terms of its selectivity. It produced almost no byproducts, said Wang. Sometimes things don't work as well as you expected, but this was a rare case where it actually worked better. The device is easy to make and relatively stable, according to the study authors. While this technology will be easy to scale up than the artificial leaf, the efficiencies still need to be improved before any commercial deployment can be considered. The researchers are experimenting with a range of different catalysts to improve both stability and efficiency. The current results were obtained in collaboration with a team of Professor Kazunari Domen from the University of Tokyo, a co-author of the study. The researchers are now working to further optimize the system and improve efficiency and see if they can produce different solar fuels. We hope this technology will pave the way towards sustainable and practical solar fuel production, said Reisner. The findings have been published in the journal Nature Energy. City trees, also known as artificial trees, use living plants and different types of mosses to capture toxins and remove... Wait, am I looking at a different article? Well, anyway, I'm going to leave this, so I hope you've enjoyed this. Please comment, rate, share, and subscribe. I'll leave this article in the description. If you'd like to support this channel, leave my GoFundMe description. If you want to follow me on Instagram, I'll leave that there as well. Peace.